Here we show you the Franck-Hertz experiment. We use mercury as in the classic experiment by Franck and Hertz, which won them the Nobel Prize in 1925. So what happens? We have a vacuum tube that is filled with mercury vapor. In here, electrons are accelerated, and we measure as a function of the anode voltage the current. From the distance of the minima of this current, the excitation energy of mercury is calculated. We will show you the complete setup of this experiment together with an example for the evaluation. So let's start by setting up the experiment. First, the control unit is connected to the computer. Next, we use a BNC cable to connect the tube to the control unit. As the next step, we have a 5-pole cable, which also has to be connected between the control unit and the tube. It is clear which end goes into the control unit and which way is indicated by a groove. The other 5 pins are labeled with U1, UH, UH2 and ground. So please be careful to fit the right sockets with the right plugs. For example, I start here with UH1, and I have the next one, the grounding socket here, then UH2, and finally the most important plug here is the accelerating voltage U1. There are more things to connect, not much, but there is a temperature sensor, the end of which goes into the tube so that the end is at the height of the anode, while the other end goes to the socket labeled T. Now, this is just a temperature sensor. We need to supply the tube also with current to do the heating. There's a special plug at the back of this unit, the control unit, that supplies the power for this. It's connected to the tube. And the knob here on the button on the right is set to maximum, since now the control of the temperature is not done manually, as you could also do with this, but is taken over by the computer. Actually, all the control of the whole system is done by the computer. The data acquisition, the temperature control, and also later the evaluation. So no other equipment is needed to perform this experiment. We are now done with the cable connections, and we can finally switch on the control unit. Now that we have switched the unit on, we have to set it to the correct operation mode. We have 4 different operation modes to choose from. To select them, we use the function button here. The 4 modes are actually, there's the single ramp, where the acceleration voltage is increased up to a preset value. Then there is the mode where the acceleration voltage is increased again and again. It's very useful for use with an oscilloscope for evaluating the measurement. Then there's the manual mode, where the functions, mainly also the acceleration voltage, can be set by using this wheel here. And finally, what we are interested in today is the PC mode, the most comfortable of all. We can use the PC to control all the necessary arrangements here in this experiment. So let's set it to the PC mode. When we've done this, we can start on our computer to program measure. In this program, you open the program Franck-Hertz experiment. Once you did this, you get the preset parameters that will work well with this experiment. For example, the temperature is set to 175 degrees the end voltage for the acceleration voltage to 60 volts. If we press continue, we can see that the current temperature still needs a while to be where the desired temperature is from the settings. If we are at the temperature we want to be at, we continue here and we can start the measurement. But this will take in real life for at least 10 minutes up to half an hour until the temperature that was chosen here, 175 degrees, is reached. So we can just start the measurement and see what happens. So you see already this red curve here evolves and develops, and now the first, second, third maximum is visible, also the minima. It takes only a few more seconds and then the measurement will be finished and all the data will be given over to the main measure program for evaluation. Here we are already. So for evaluation of the excitation energy of the mercury, what we need to do is to evaluate the distance between different minima here. There are different ways to do this. One is the survey function you find here in the program. If we choose it, we get two cursors which we can position at two adjacent minima. And at once we can see at this window here the value delta x, the distance between those minima is 4.91 volts, which is actually the value that Franck and Hertz got in their experiment back in 1913. Another way to do the evaluation, the more detailed way, is to use the function curve analysis. So we click this button and we want to visualize the results, and once we did those two clicks, we see that all the minima and also the maxima are indicated here in this graph. We also have then numerically the values in this table. From these values we could calculate always the difference between adjacent minima, for example. Then we calculate the average from this, then we get a more precise measurement. It's very close to the value that's given in literature and that also that Franck and Hertz already measured. The excitation energy of mercury is 4.9 volts.